did that as well too. All right, get out your book of truth. We're taking a quiz. Well, do you remember what I said it was going to be on? Danny, everybody listen. Danny, what's the quiz going to be on? Literally, I said, look at your sheet that I did not collect, remember? And I said, you're looking at the quiz. So those three things.
No, wait, no. What are the saying for the
no. So, hey, no joke intended, but it literally all I did was take the worksheet, say generate new questions, and then deleted a bunch of them. There's 16 questions. This will take you 10 minutes, even though there's 16 questions. Most of you be done in 3 minutes, right? But some of you will take the entire time. All right. Good luck. You can start as soon as you get to you. There is no secrets here.
Answer everything. Everything's not good. Unless it's not good for them. Yeah.
I would hope so, because this is probably the easiest quiz of the year. The easiest quiz of the year. Last one was pretty easy. This is easier. All right.
What's there?
Hey, I apologize. I'm going to talk while you are taking your quiz. All right. Plan of attack. Not you yet. You guys, we already said this to a couple. You have to watch the videos. No, you got to get on Microsoft Teams. The ones that you missed, you've got to watch them. Come to me with any questions what you got them. If you do not watch those videos, you're going to fail. No joke, fail big time. If you watch them, at least we got a chance of moving forward. Today, there's a lot of stuff we're going to do. These kids are going to be like all over it. They're going to get it like that. You're going to be looking at like, I don't know what's going on because you haven't had those classes. But trust me when I say you'll be like them if you watch those videos. So you missed as much as you weren't here Friday. Yeah, she was here Friday, so she got one extra class. You were not. So she's probably still pretty lost. Right? So, but I guarantee you're really lost. Bree is so lost that we're not even in the same universe as the rest of us. Right? She's got the most work to do. But you guys, if you put some effort into it, I guarantee this is an easy step. Okay? I don't know if I'll even give you the quiz. I'll probably just go right to the test. I got to have a longer conversation. Anybody done? Too quick. Somebody's almost done. Caleb's almost done. Mike is almost done. Jenna's almost done. Not a race though. I just made that. red ink. Five minutes. Chris, you still working? Anybody still working? Okay, keep going. Okay, 1 minute, 1 minute. All right, make sure your names are on it. You missed one.
Good job.
All right, what do you think? Easiest?
No. Yeah, it was
Well, there's always that one. Can't all be as smart as you. What do you think? Easy? Yeah. Okay. Believe it or not, that was kind of speech I was giving to Bree there, and I mean, you're going to take today's class, all of a sudden it's going to start to click. You're like, okay, yeah, I got it, and it's not going to mean anything to them, and they're going to think that we're doing like, black magic because it looks weird, but the reality is we just did, I don't want to say the hard work because it really wasn't that challenging. Pass behind. It really wasn't all that challenging, but for an observer of the class who doesn't know geometry, it definitely seems like what we're doing is challenging. All right, a couple proofs today, a couple skills that we'll get as well too. The skills kind of build upon what we've already done. They're not, it's a little bit of algebra, not much. I will say a couple of you still are weak on solving multiple step equations. I told you at the start of class that the math that we do in geometry is really right. 2 plus 3, that sort of thing. It's true, but you absolutely need to know how to solve equations with variables on both sides of an equation. If that's something, I've had most of you before in pre-algebra, and last year you had algebra 1. If that's something that you're still weak on, you're like, yeah, I know. If I put the variables on both sides, I don't even know what to do. I got to see you for some tutoring, right? I can help you, but I can't spend time in class helping you, that sort of thing. All right, homework, any questions? All right, they were all proofs, right? I'm just going to collect, since I have to check your work. I'm just going to collect one. Make sure that lines up in the basket. For the rest of you, we just took our quiz. We got nothing this week. I'm going to tell you, I believe that somewhere around, I don't know, Wednesday, Thursday-ish, we might reach a point where I'm going to ask you guys, just be honest, hey, do we need a practice day or we got this stuff? We need a practice day, we'll take a practice day. If not, we're going to move right on through the test. It would be kind of nice if we did a practice that way. We wouldn't come back from a 3-day weekend and take a test sort of thing. But if we make it to 4-7, we don't need a practice day. But I'm saying I think maybe after today's and tomorrow's class, we might want to take a practice day just to make sure that we have these skills down solid. Here's your homework. Thank you. All right, this is the chapter where I typically see people start to run with geometry, and I see those people that don't pay attention, they get left behind. So please, if we're doing so, I'm not talking about the more complicated stuff. I'll tell you when we do something complicated. I'm talking about the basic stuff. Hey, can you look at this and understand the basic reasoning? If you got that, then you're exactly where you need to be. But certainly for some people, this is the chapter where it becomes a little bit overwhelming. This is the heart of geometry right here, proving 2 triangles are congruent. And it's not that bad. We got a really important triangle today that we'll see a lot of. There's 2 important triangles, Isosceles and right triangle. We get the Isosceles today. I can't remember if tomorrow's right triangle or the day after that. But actually, no, tomorrow's not right triangles. But yeah, right triangles are important as well too. We good? Everybody got it copied down? Here we go. All right, so Isosceles triangle theorem. So clearly we're going to get at least one theorem today. We're going to get a lot of stuff today. It's 1 theorem or 2 theorems and about, I don't know, 6 corollaries. It's a lot of stuff. The nice thing is that they're all easy. They're ridiculously easy. We got to put them in our book of truth, right? So they're going to be sitting right there for you to use. Of all of them, one of them we use a lot. The rest are just kind of, they're there. All right, here we go. Recall from the last class where we're going in this chapter. 2 basic things. If I want to show that 2 parts are congruent, the basic schema maneuver is this. I'm trying to show that this side is congruent to this side, or this segment's congruent to this segment, or this angle is congruent to this angle. We basically say that they're part of two different triangles. We show that the two triangles are congruent, and then we claim CP/CTC. Yeah, I don't want to give this CP/CTC short shrift, and like I'll have people there that literally 2 months from now, like, I never understood what CP/CTC meant. You got two triangles that have corresponding parts. Left side goes with left side, right side goes with right side, bottom with bottom, or the angles. So it says the corresponding parts of congruent triangles, they are congruent. So basically the sides or the angles that match up for congruent triangles, those parts are congruent. So to show that two parts are congruent, this is the basic scheme maneuver. We're going to do it a couple times today. Hey, show the two parts are part of two different triangles. Show me that the two triangles are congruent, and then claim CP/CTC, and you're done. The second thing is to show that two sides are parallel. We're not going to see this today, but just always remember, keep this in mind. It's the same basic idea. Show that those two segments are part of two different triangles. Is that me? No, I don't even have my phone today. Show that the two segments are part of two different triangles. Show that those two triangles are congruent, and then we're going to claim that the converse to the alternate interior angle theorem. Basically show that because the alternate interior angles are congruent, therefore the two sides are parallel. Here comes the new stuff. Ready? Here we go. In box 1, most of the time I don't have kids put this in the book of truth because it's kind of painfully obvious. If you want to put it in your book of truth instead of on the piece of paper, go for it. But I'm going to say it's an isosceles triangle, right? You should know what that means by the time you get to high school. So that's a triangle with two sides that are congruent. Draw me one, please. All right. How do we show that the two sides are congruent, by the way? Put little tick marks, right? So put 2 tick marks. Looks like an angry something. I don't know. It looks like the dude from Nightmare Before Christmas. Oogie Boogie, something like that. What's his name? Come on, you've seen the movie, somebody. None of you?
I've seen it, but like, I don't remember.
The dude, Oogie Boogie or something like that? It looks like him. Right. He is the Boogie. Okay. If you've never seen Nightmare Before Christmas, watch it. It's a good movie.
Good. I'll take it back.
Changed my life when I saw it.
I've never seen it.
You've never seen it?
No.
I haven't seen it either.
It's an artistic masterpiece. I'll just say that.
I agree.
And it's a kid's movie, but as an adult, you can appreciate it. It's a solidly good movie. Right. And it's stop action, too, so it's crazy cool.
Stop motion.
Is that what it's called?
Stop motion.
Stop motion, okay. Stop action, whatever.
Same thing.
No,
All right.
it's not.
Hey, we're to give a couple names to Oogie Boogie here, right? Guess what we're going to call the top?
Angle.
It is an angle. Right. Now, I got to be careful. I just said that we're going to name it the top. It's not the top because it could be turned sideways. We call it the angle that's included between, remember included angle? The included angle between the two congruent sides is called the vertex angle. Okay. Occasionally, maybe they may talk about look at the vertex angle. I probably would have to search in the book for that. Do you know what we call the two sides that are congruent? Anybody? That would be a good name. They actually call them the legs. So the two sides that are congruent are called the legs, which only leaves a couple parts. What haven't we named?
Bottom.
What are we going to call the bottom? Except it's not really the bottom. That would be good, but the problem is you can turn it sideways.
The feet.
Legs, feet, that would make sense. The foot.
The base.
The floor, the base, right? It's called the base. Lastly, the only thing we don't have labeled are these two angles right here. What are we going to call them?
Bottom angles.
What?
The
The bottom angles, the base angles? Yeah, we call them the base angles. The base angles are the angles, look at your picture, that are opposite the two congruent sides. You see the two congruent sides, the one that are marked in red? So we're talking about the angles that are opposite the two legs. Those are called the base angles. That's something that you will see all the time. It will say the base angles. I don't think I've ever seen it say the vertex angle. If there is, maybe it's once or twice. But legs and base angles, not necessarily the base, but occasionally the base. So anything below the vertex angle, you're going to see this, and you're going to be expected. So if it's in your book of truth, great. If it's something that you'll remember, I mean, I'm not going to forget this, not because I'm a math teacher, because it's, okay, it's an isosceles. There's only so many parts to it. They say the base and the base angles, I kind of know what they mean. So quick note, the angles that are opposite the two legs are called they're called the base angles. And we'll see this a bunch of times. And the second note is this. Even though this is called the base and this is called the vertex angle, I can take this triangle and turn it 90 degrees so it would look like that. It doesn't mean that the bottom now is the base. The base is still the side that is opposite the vertex angle. The vertex angle is the angle that's opposite the base. The base angles are the sides that are opposite the legs. And so I can turn it either. Those are probably the orientations that you'll see it. Okay, so don't be confused if it says base. Well, I thought base meant bottom because you literally said, I did. And then I said caution. It doesn't necessarily mean the bottom. We okay? All right. Let's do a proof. Let's do a proof. All right, here we go. Bree, proofs start with this basic visual representation. You're given something that says a given and something that says prove. And then typically, not always, you're given a picture. You're not given this part right here. You make this part. You make this big plus symbol. Things that go on the left are called statements. Things that go on the right are called reasons. All right, so the given is always our first statement, and our last statement is always the prove part. Hey, a couple of you, when you're doing proofs, guess what you've been putting for your reasons for the last statement? Like, I'll see somebody write the word P-R-O-V-E. Where did you get that from? Right? You got to give me a reason for this. Hey, look at the bottom. What are we trying to prove? We're trying to prove that two things are congruent to each other. So guess what we're gonna do? How did I start the class? With a recall.
With a quiz.
Yeah, true. How do you show that two things are congruent to each other? How do we show that two things are congruent to each other? Show me that those two parts are part of two different triangles. Prove that the two triangles are congruent, and then call CP/CTC. So guess how we're going to do this proof? We're going to make two triangles and show that those two triangles are congruent. So how do you want to make two triangles? Okay, and I like you said cut it in half. If we cut it in half, what are we really cutting in half? Okay, if we cut it in half, where do you start it? So if you're doing that, what are you truly cutting in half? The vertex. So I'm going to cut the vertex in half, Danny. When you cut something in half, you make from Friday's class. When you cut something in half, you are making starts with the letter B. You're making, somebody help? What? You're making a bisector. So it says construct an angle bisector of construct a bisector AD. Where's the D? It's not there, so we are making AD. So I'm cutting A in half, and I'm making the other part, because you're making a segment, right? A segment or angle bisector, you're making a segment. So I got to have an other point there, D. I'm making that. That's why it's in red. Why can I do that? It's called construction. You are allowed to construct whatever it is that floats your boat, as long as you don't violate any math rule. I can cut an angle in half. That's easy. We okay with that basic idea? Now, you may not understand why we want to do it that way, but remember our basic idea to show that two things are congruent, show that those two parts are part of two different triangles now. See the triangle, two different triangles. Now we're going to try to show that the two triangles are congruent. Then we call CP/CTC and we're done. Connor, what two angles are now congruent? Okay, remember the middle letter has to be the vertex of the angle. You can't start at the middle and then claim the two endpoints. So say it again. The middle number has to be the angle itself. What did we just cut in half? A or D? So the middle letter has to be A. So say it again. And so we got to say BAD, CAD. So Caleb, this is on you, right? When you on your quiz, right? When you wrote all your things, you forgot the little angle symbol. Make sure you're putting your symbols. Everything else was right except for one problem on your quiz. And it wasn't that you left off a symbol. We okay with that statement? Oh, we just said they're congruent. We could put congruency symbols. Bree, when we show that two things are the same measurements, right? And we're talking about angles, we can put these two little red arcs. Tick marks mean sides are the same. Arcs mean angles are the same. And I think Amaya knows what to do next. Sure you do. What's the one thing that we used all Friday besides angle bisector? And that you can visually see in the picture that's the same in both triangles. Say again? Yeah, but where's the other side? I see a side and an angle. Where's the other side? And that's because of, starts with the letter R. Boom, look at that. Good job. AD is congruent to AD. Why? Because it's reflexive. Remember doing that? You should be like, I'm not going to say it's in every proof. It's not. But it's in so many proofs. Hey, look, reflexive prop. I already knew where we were going with this, by the way. She was like, well, I already see an SAS. Can everybody see the SAS? Okay, we're going to go back to the conversation we had before. That it's going to seem like black magic, right? And everyone else is going to understand. And they're like, oh, yeah, I see it. Okay, for the people that had been here, you see SAS really easy? Okay. So we got to have a triangle congruency statement, Matt. Don't screw it up. Now I'm going to see if you got your quiz right or wrong.
Okay. So
He's going to give me a triangle congruency statement now.
I don't have enough tick
SAS.
marks.
So give me the triangle congruency statement.
BAD
Is congruent to. He said BAD. So once you set those three letters, you got to follow the same pattern. What?
to CAD.
CAD. So he went B up the one tick mark to the congruent angle down the two tick marks. So up the one tick mark to the congruent angle down the two tick marks. So triangle.
Triangle BAD is congruent to triangle CAD.
Perfect. Why?
Because it is.
We have three possibilities. And if you had been paying attention, I already told you the answer. SAS, and I hope that was on your test because that was the first, I don't know, 2 questions on the quiz. It was SAS. It was the first 2 questions, I'm pretty sure.
Oh, right, the answer?
Yeah.
Yeah.
Okay, we good? Hey, show that the 2 parts are part of 2 different triangles. Show that the 2 triangles are congruent. What's the last step? And you're done. It's like it's not even any thinking going on, almost, kind of, sort of. Could you have done this proof by yourself? No. This is a hard proof because this construction right here. Okay? But the proof, once you see that one construction, kind of flows really quickly. By the way, what did we just prove? What was the given? What was the given? We had a triangle with, I'm going to go all the way back to the start. What were we given? What is that?
A triangle.
What is that?
An
An isosceles triangle. What did we just prove? That's not what we proved. That the 2 base angles of an isosceles triangle are, boom. Very good, Cadence. Very good. So that must be a theorem because we just proved it. This is a very important one. Write this down, Book of Truth. This is 4-1. Nobody remembers 4-1, so we simply call it the isosceles triangle theorem. Haley, right? Book of Truth. Hey, Karis, where's your Book of Truth? This has got to go in your Book of Truth. Okay, just make sure you transfer it. The isosceles triangle theorem basically says this. If you got an isosceles triangle, oogie boogie here, then the angles, the base angles, are congruent to each other. Not a hard proposition. And we proved it, by the way. It was good. So, Bree, at this point, your knowledge of geometry is that if you have an isosceles triangle, then these two angles, the base angles, are congruent to each other. Congruent means same measurement. Different looking angles, one's pointing left, one's pointing right, different looking one, but their measurements are the same. That's what congruence means. Two different things, but they have the same measurement. And we have the equal sign with a little wiggle over the top. That's the congruency symbol. Yes? Okay. Not on homework yet. All right, well, let me get to a break while they're doing something, and I'll help you. All right, we good? All right, here comes a whole bunch of them really quickly at you. These are all going to be corollaries to this theorem. Remember, the idea of a corollary is they're derived from one theorem, right? Every statement about, I think we got 3 of these. They come from that theorem we just talked about, the isosceles triangle theorem. I refer to them as leaves of the tree. So that the tree is the tree of isosceles triangle theorem. So all these things are dealing with the fact you got an isosceles triangle. They don't have names. They're just called corollary 1, 2. Every time we get to a corollary, it's called corollary 1, 2, 3. Well, that's a problem. So we got to say corollary 1, 2 theorem, whatever it's attached, the tree. Here's the first one. Corollary 1 to theorem 4, 1. How are you going to remember this? You're not going to remember this. No chance in the world. So it better be descriptive. It's pretty simple. You ready? Oh, by the way, we have to prove corollaries too. I'll do them for you real quick. It says that if you have an equilateral triangle, it's also equiangular. If you have an equilateral triangle, that's all 3 sides are the same, then all 3 angles must be the same. So if you have an equilateral triangle, all 3 sides are congruent. It says that, well, all the angles must be congruent. You want to see how easy this is to prove? Hey, what kind of triangle is an equiangular or equilateral? Sorry. So therefore, that's got to be congruent to that. Hey, turn your head to the left. What kind of triangle is that? And then that's got to be congruent to that. I just proved it for you. That's a pretty easy proof. And that's the picture. We have already had this before. We've actually figured out how big are the angles of an equiangular triangle, by the way. How big are the angles of an equiangular triangle? How much? Why 60? Because it adds up to 180. That was that one theorem. Therefore, if they're all the same, then 180 divided by 3 is 60. That's going to be another corollary, but we'll get here in a second.
So it's 1 of them 60 degrees.
Say that again?
One angle is 60.
One angle of a what kind of triangle?
And
No, you could have a 30, 60, 90 triangle. Which we will. That's one of the special right triangles. Okay, we good? Corollary 1, there's 3 of these. Corollary 2 says the following, what I just said. And Cadence proved it to us. Based upon that other theorem that we had that, well, the sum of the interior angles of a triangle is 180, and there's 3, and they're congruent by corollary 1. And corollary 2 says, well, they all must be 60. Duh. That's an easy one to prove. How come I can't put one of those on the test? Tell me if I'm going too fast. I don't want to. It's a lot of writing today. Ethan, your head's above water?
Yeah.
Okay, good. Bree, can you see the surface from way down below? No. Okay. You're sinking very quickly. Right. What does this basically say, Bree? If you have what? If you have an equilateral triangle, what?
Um,
All right, you're getting closer to the surface. That's all it says. All right, here comes the most important one of the, it's almost more important than the Isosceles triangle theorem, and it's a corollary. Here's what it says. It says this. If you bisect the vertex of an isosceles triangle, that bisector, the red dotted line I'm about to show you, is a perpendicular bisector. If you have isosceles triangle and you bisect the vertex, then that red dashed line is a perpendicular bisector. I'm going to have to prove that. It's a perpendicular. Well, there's perpendicular. Well, how do I show that it's a bisector? What would I put here and here? No, bisector. If you bisect a segment, what did you just make? What kind of lines? Segments. No, we're talking segments, not angles. You cut it in half. So how do I show that they're half of each other? I shouldn't say half of each other. How do I show that they're half of the whole? If they're each half of the whole, what does that mean about the two parts?
That they're equal.
So how do I show that they're equal? Tick marks. Okay, so this is the picture of that statement. I didn't really prove it.
Kind of explained it.
So it says, if you make a bisector of the vertex of an isosceles triangle, wait a minute, we got a side, we got an angle, what do we know about reflexive? And they're congruent, we have SAS. So that means all the corresponding parts are congruent. So why is this equal to this? CPCTC. Wait, why is this angle equal to this angle? CPCTC. Now here comes the kicker. Why is it 90? Why is it 90? Why does it have to be?
because it's not a direct line.
Why? Why? She said it's supplementary. Why? Straight angle, right? By CPCTC, this angle and this angle are the same. I'm looking at the where the bisector comes down, and they're supplementary because they make a line. Well, 180 divided by 2 is 90. That's why it's perpendicular. Why is it a bisector? CPCTC, because of SAS. Well, that was pretty easy to prove. I said this is the most important one. You're going to see this over and over and over and over again. It's going to say, make a bisector of an isosceles triangle. The so what is, this angle is 90 and these two are congruent. That's the so what. Okay, we all right? This is a lot of writing to do today. Perpendicular bisector of an isosceles triangle, right, is also an angle bisector. One more proof, and then we'll call it for proofs today. Here we go. Is that an isosceles triangle? Yes or no? That's what we're about to prove. Right. All right, smarty pants. Right? He says yes, it is. Well, let's see if he can prove it. You ready? Here we go. Bree is a proof of. We have to prove everything. I can't make a statement like I have in the past. Say, hey, trust me, this is true. Everything we do in geometry must be proven. All right, so we got the given, and well, oh, this is going to take a while. We're going way down there. All right, smarty pants, what do you want me to do first? Oh, by the way, once again, what are we trying to prove? Some part is congruent to another part, so what's our basic schema maneuver? What's our schema maneuver? Before that, though, I got to show that those two parts are part of two different triangles, show that the triangles are congruent, and then say CPCTC. Okay, that's what we're going to do. All right, I don't see two triangles there. What are we going to do? Do you want to make it an angle bisector, or do you care? We have the option, by the way. We can say this. We either can make an angle bisector, right? Or we can make it a perpendicular bisector. Either one. A perpendicular. I can't say it's a bisector. I don't know if it is or not. So you have a choice. I'm going to suggest that you go with option number 1, make an angle bisector. Okay, so we're going to make an angle bisector through construction. It's the same things we did in the other proof. Chris, if we make an angle bisector, what can we say now about the parts of the triangle? Say it again and say it correctly. It's the same statement I made to Connor. If A is the angle that you're bisecting, the A's got to be the middle letter of your angle. So if you say DBA is the same as DCA, well, that's the given. You just bisected A. So what does that make? Which two? Yeah, which two? And so B angle BAD is congruent to CAD. Now you said it correctly. So BAD, bad CAD. Right? Connor, you got that idea now? Okay. Well, that's the definition of an angle bisector. You made one. Well, the definition of angle bisector is well, it's a segment that cuts an angle in half. If it's in half, then it means the two parts are congruent to each other. Okay? All right, smarty pants, go. I got an angle. I need a side somewhere. Give me a side. We have the reason. Help them out, Amaya. Reflexive property, right? So AD is congruent to AD. Now we got a side. I can put a tick mark. Great. Wait a minute. I still have angle, side. I don't have that one yet.
The two BD and DC are.
Well, how do you know that?
Because D is the midpoint.
How do you know it's the midpoint? We didn't say make an angle bisector, or say a segment bisector. We said make an angle bisector. I don't know, it's true, but I don't know that these two are congruent yet. This is a hard one. You might not get this one. Do you agree that we got an angle, and a side? We need something else. Either another side or something else.
Is it BA and AC because the BC are congruent?
Well, it turns out they are, but we can't just claim that, though. Here's the hard one. Are you ready? If two angles of one triangle are congruent to two angles of another triangle, finish the statement, then what? Say it again, Madison. This was a long time ago. I can't even tell you what the theorem is. But the theorem stated this, right? If two angles of one triangle are congruent to two angles of another, then the third angles must be congruent. Why? Well, everything, remember, each side adds up to 180. So if you got two that are congruent to two, then that only leaves one other angle and it must be congruent. I don't remember the name of this, but we can claim that this angle is congruent to that one. And I had to use really small font right there because I can't remember the name of the theorem. Because I don't have a book of truth, I just got the math book. It's called the third angle triangle theorem, something like that. If I were to give a name to it. Two angles of one triangle are congruent to two angles of a second triangle, then the third angles must be congruent. If the third angles are congruent, then I can put congruency symbols, and we'll use Madison's idea of, wait, look, well, they both make a line, therefore they must be perpendicular to each other. Therefore, why are the two triangles congruent? So why are the two triangles congruent? You just showed that this angle is congruent to that one. And I put 90 degree because they make a straight line. So why are those two triangles congruent? We got three options: SSS, SAS, ASA. Which one is it? Where do you see an SAS? Where do you see an SAS? I see instead, I see an ASA, right? Angle, side angle. Can you see that? All right. So how does this proof end? How have they always ended? CPCTC. Corresponding parts of congruent triangles are congruent. Show me that the two angles are congruent, then their corresponding parts must be congruent. CPCTC. Yeah. Oh, what is it?
It's corollary 1 to 311.
Corollary 1 to 311. Good luck remembering that, right? That's why you got a book of truth. So if I were to write corollary 1 to 311, then I would have to remember what the heck it even says. So that's why I didn't write it. We good? What did we just prove? What did we start with? What did we just start with? A triangle with, is that an isosceles triangle? No, it's not. Where does it say isosceles? Doesn't. What does it say you have? If you have a triangle with two congruent angles, then it's an isosceles triangle. You don't start with an isosceles. So this is the isosceles triangle theorem backwards. In other words, if it's the isosceles triangle backwards, then we call it the, starts with the C. How do you say things backwards in math? Geometry. It's called the converse. The converse to the isosceles triangle theorem. So this is theorem what? 4-2? 4-2. Okay, 4-2, write this. It's the converse to the isosceles triangle. So this time you don't start with an isosceles triangle. You end with a triangle, isosceles triangle. All right. We got 2 minutes after the bell rings before 10th graders are allowed to move. We didn't get to actually do any problems. The problems come from the fact you got an isosceles triangle. That means the base angles are congruent. That means the sides, two of the sides that are opposite the base angles are congruent. So tonight for homework, they're going to give you some easy ones, and they're going to give you some ones that involve a little bit of algebra. Let me show you one example. Oh, we didn't get to the corollary. We're going to have to finish this tomorrow. Yeah, no homework tonight.
No, it's so.
If you want to try it, you can, but I got to finish this class.
All you need is this theorem finished.
You need this and the corollary.
I'm just not
Okay.
doing 13.
Well, why would you have failed? You got the first one right, you got the second one
14
right,
was easy.
you got this one right, you got this one right.
I don't even understand the answers above it.
That's not right, that one's right, that one's right, that one's right. Most of them right. So this says LM. Find the LM. Find the LM on the triangle congruency statement. You see LM? Is it? Tell me what letters it is. The first and second letter. Yes. So what's the first and second letter right there? When you put it in LM, what that means? This one says SUT. So how does it go? What's the pattern? And so you should write SUT. And you wrote. I mean, you did it right. Fix that one, and then.
I think you gotta get a haircut this weekend. I had cheating going on in my art class.
Who is it?
He was
That's
copying
period 4?
his
Yes.
7.
He's the smart. Who's this?
Richard.
Richard. Thank you. All right, e-learners, we'll end it right there. If you have any questions, ask me questions. If not, I'll see you guys tomorrow.